So I've set the buffer length to 7FFF hex, which is 32K, and there's nice advantages of using a round hexadecimal number, a load of ones in binary, in that you can wrap the read and write pointers just with a simple AND statement. So you just carry on incrementing and then just AND it with that, and it will automatically wrap at the end of the buffer. So that's good. However, 32K at 48 kilohertz is only 3/4 of a second. So I'm mallocing my my buffer here to be, and I'm using a size of 32-bit, so that's 4 8-bit bytes per 32-bit word, and I've got 32,000 of them, so I can run a delay of about 3/4 of a second. So I'm going to hard code the delay wherever I've put that here to 24,000, so that's half a second, which should fit easily in my 3/4 of a second buffer. I've got a little sequence here. That's the input, and this is the delayed output. And if I bring the input in, we've got ourselves a delay. Excellent article in Pete Warden's blog here about the physical layout of the Raspberry Pi Pico's memory. Essentially, those 256K of RAM are made up of 4 64K banks, and you lose most of the first bank to the vector table, which is an array of function pointers pointing to the various routines in your code, data, which is variables that are initialized at start, and BSS, which are variables that are not initialized at start. So you're only really ending up with about 192K of RAM. So we have to find out how much of that we can use. So in my code here, I'm using malloc to create the buffer, and we're storing 32-bit samples, so that's 4 times 8-bit bytes, and I've found that I can get up to 64,000 32-bit words before the malloc fails and my code exits here. So let's look at what those 64,000 samples actually means. At the moment I'm running at a sample rate of 48 kilohertz, so that means I can make a maximum delay of 1 1/3 seconds. Sure, I could drop the sample rate to 32K, 22K, 11K, but I'm quite liking the idea of quality, because there are a lot of bucket brigade device delays around that do some fantastic stuff, but they're reasonably low audio quality, whereas this running at 48 kilohertz is going to be a lot better in terms of quality. So I'm loath to drop the sample rate below 48 kilohertz. And the other important point is that the PCM 5100 and the 1808 are both stereo I2S devices, and it'd be nice to build a stereo delay, and if I was to do that with the Pi Pico's built-in RAM, that's twice as much memory it would consume. I'd only have 2/3 of a second maximum delay, and that does not feel enough to be musically useful. So I'm going to have to find more memory.